All right, I think we're going to get started here, guys. Thanks for coming today. I know it's getting late and everybody wants to drink soon, I have a feeling. So we're going to have fun here. My name is Pete Crosley. I'm the CTO of WebTrends, and I'm in charge of all the technology and architectural directions that we take as a company. And one of the things that many of you may or may not know about WebTrends is we've been around for quite a bit of time. I like to say we're a 20-year-old startup software company. Originally, we started collecting data around even devices like SNMP, network monitoring, traffic devices. And then we did some log analytics, and everybody's probably heard of some of the old historical log analyzer products that we've had. So fast forward to now, and we're in this world of devices and websites and cell phones and cars and refrigerators and toasters that all produce data for us. And really, WebTrends has turned into this company that's able to collect any type of data, any width of data, and at a high speed rate. So it's a data ingestion and data delivery system. So I'm going to talk to you a little bit about this journey that we've taken and kind of how the architecture and the technologies that we put in place really helped craft where we're going as a company, and also kind of some of the use cases that we had to solve. A little bit about me: I've been working in this industry for about 15 or so years, dealing with big data. And I like to say at WebTrends, we've been doing big data before big data even existed, because we dealt with files and log files and just things that we have no way to store that information. So my spin on it has been really building these enterprise-ready SaaS solutions and trying to figure out a set of technology that we can use to really allow us to be successful as a company. So our marketing guys built a slide for me, and I just stand and start watching it because it's kind of mesmerizing. But the whole idea of data is about how fast you can consume it and how fast can you actually do something with it, right? You know, when it comes to marketers, people really need to make data available to you in a timely manner. Otherwise, it's either latent in the sense it's too late, you've missed it, you can't take action on it anymore, or there's no way for you to actually see the bigger picture about that data. So getting the electrons in your data, because electrons obviously moves the data across the wires, right? That's the whole kind of the pun I'm going on here with my talk, is that if we can move those faster and get those to where you're trying to send that data and to make it more valuable for you, it's going to be a better value to your company or your product offering that you're working on. So one of the things that has really changed over the last few years is the amount of IoT data has now surpassed the user-generated data. So everybody here has cell phones, and they're all looking at their emails, Facebooks, all those types of things. That data that we have in that we generate ourselves is now being dwarfed by the amount of data that's autonomous and from the sensors that are being produced in the world. So really taking that and looking at that a little bit differently is that we're missing a lot of information and potential other valuable insights that we could have to our bigger picture of our data sets. So what does that mean? So Tesla Motor, I heard this stat, it was pretty interesting. It's that Tesla Motors has more than 300 million miles of data collected on driver behaviors, right? Just from the cars that they have sold. That's a crap load of data to be able to influence how you develop a product. That's a great example where somebody has taken a data set and in real time and feeding this data back over the systems of the car and being able to optimize the way the braking works or change the way the driver patterns happen for those individual vehicles. Conversely, look at Google. They have the autonomous car, right? It's not widely accepted, and it's not like you can't just buy one, right? I can go down to the mall and buy a Tesla. I think it's kind of weird. You can go to a mall and buy a Tesla. But you go to a mall and buy a Tesla, or you go and Google, and you have to get signed up into the right area where you can drive one of these cars. They only have 100 million miles of driver data. And it's a very smaller data segment. So here's a good example of somebody who's introduced a product into an ecosystem, a vehicle, and able to take that data and turn it around and actually make a better product about it and improve it and make people very happy. They just do a software upgrade, and now you have better performance because the way people drive have determined that you need to change the fuel injection rates or something like that. Or not fuel injection because it's a Tesla, but discharge rates. There you go. But there's a great example, right? So I find that very interesting from the standpoint of how do you leverage data and how you make value out of that information. And I just...
Hey, why don't you ask Susan?
George is Susan?
Yeah.
Yeah, why not Susan? I should be friends with Susan. Of course.
So with this data that we have coming out of our
okay.
system,
I'll see you guys.
our worlds are going to collide. The idea of data that's being present in the physical compared to the digital.
Why?
You can turn that up.
Don't you see this?
You can turn that up.
If Susan comes into contact with this world, his worlds collide. You know what happens then?
Well, that was really a stupid thing. You know what's gonna happen now?
Worlds collide.
What? Yeah!
Because this world is your sanctuary, and if that world comes in contact
Yes, it blows up. So if you know that, what did you tell Elaine for?
You don't want to be a
Kramer
George.
told me about the world.
You don't want to be
You
so
couldn't
stuck
figure
in your
out the
ways
world's
that you
theory
can't
for
work
yourself?
together.
It's just common sense. Anybody knows you gotta keep your worlds apart. Did you just say vault?
Yeah, why? Did I use it wrong?
You got that from Elaine.
Yeah. So what?
Well, it's a little strange. You're gonna start to talk like Elaine from now on?
I don't know. Anyway, I thought we'd all go to a movie on Friday.
We'd all go to a movie on Friday? This is not good. Worlds are colliding. George is getting upset.
Anyways, I wanted to share that with you because I find it funny because that's how people look at data, right? You have data that's being generated in your CRM systems. You have data that's being generated from your website. You have data coming from your mobile devices. You have all this data coming around. And if you don't put it together and you don't have any way to make that data actionable or do something with it, you're losing out. And you're, in the case of George, he didn't want that to happen, but our worlds are colliding. So our ability to generate data in this right now has increased 100-fold, and the volume of this data, as I was mentioning, has increased so much that it's been said that because our volumes has increased 100-fold, it's now 1/5 of all the data being processed is IoT data, so of worldwide data collection. And of that 1/5, 78% of all the enterprise customers are now going to be adopting a IoT strategy for 2016. That's according to Forrester Research. So the amount of data that we're actually looking at is pretty significant. So if you're not paying attention, you're going to get caught by a tidal wave of data. And this data is everything that you can think of that everybody thinks about of data. And if you're not working with the data in a way that you can actually process it, you're not going to get any value out of it. So we're going to talk about some of the architecture decisions that we've made at WebTrends and how we're going to actually apply that to the data that we talked. And we'll get some technical technologies and things like that. So high level, this is what WebTrends does. We have a tag that collects data. It could be from any type of data source that you want. It's a pipeline architecture. So when I talk about data and I talk about real time, this is something I would like to know. Who here says real time is under an hour? When you look at data, is that considered under an hour? Okay, so if, what about under 15 minutes? Real time? Is that still real time? What about 5 minutes? 5 minutes? Okay, what about under a minute? Now, if it's above those values, do they feel that that's no longer value? That's no longer real time? What about a second? What about 500 milliseconds? Anybody less than 500 milliseconds? What are you working at? What's your?
Not where I'm working at, just what I thought real time is.
OK, but it's a good understanding that people don't understand, or not don't understand, but they don't grasp the concept of real time, right? Real time can be, to WebTrends, is now. Like, it's not 15 minutes ago. Because 15 minutes ago, your data's gone. Like, you might have missed that opportunity for that customer. You might have missed that opportunity for some actionable item. So in the case of WebTrends, real time is what's happening from that data sensor or data point or website or phone right now. And we're going to show this to you in a second. And I forgot to say this. So if you guys have cell phones, I have a little game that we're going to play here. And there's money involved. So you guys can earn some money today. Gift cards. If you have a QR code reader on your phone, great. If you don't, you should get one. Because I'm going to put a QR code up here in the future. And if you get that and you can use this, and we're going to play a little game and do some data generation and actually see this pipeline at work. So we have an API that collects information. Then we do some processing on that data. The fundamental way that data needs to be handled through this pipeline is a stream mechanism. As you start processing that information, you need to be able to move that data through that pipeline consistently without having it go through, quote unquote, a batch process. To be an in-the-moment, Internet of Things processing system, you will be left behind if you're waiting for data 15 minutes in the rear. That tidal wave could change the way you want to do something. And depending on your application, there may be different variations to that. But I just wanted to say it's pretty critical to us at WebTrends. So we have this processing engine that takes all these events that are being processed and aggregates them and starts enriching them through augmentation of geodata, all being pipelined and processed during that stream of ingestion. We then decide to store it. That storage process gets stored in two ways. We have something that's dealing with our streams platform, which is the in-the-moment data that's available, and I'll show this to you right away. And then there's the storage for offline historical value. So you need to look at both the standpoint of real-time data sets and historical data sets, but to the end user, they need to be the same, right? Everybody agrees that they need to be queryable and looked at as a single source, potentially. Because you may want to say, what did this person do today or right now, and how did that differ from last week? You know? And that needs to be able to be queried and identified holistically. And then we have this core of like different capabilities where we process that data and manipulate accuracy at scale calculations and all the augmentation or all the calculations and the aggregations that we need to do across these raw data sets. Because we store every single thing at the lowest level, which is the event detail level of the device or the sensor or the website or the click, we're able to then reconstitute what a visitor is, what a person is, or what a session is. So, and then obviously the system here at the end has the ability to take and send the data to different applications. We build applications at WebTrends that allow us to have UIs on top of our APIs, but those also can be data delivery capabilities, like let's send it to Azure or AWS, or put it to a SQL database, or send it back into HDFS, or send it off to Kafka again. Those are all just different types of technologies that we can integrate and send our data off. So really thinking your data in three different phases. You have your ingestion, your producers, your stream delivery capabilities, your analytics functions, and then you have your delivery functions. And if you break your system up into those four different kind of tiers and then apply different Lambda architecture technologies on each of those phases, you will have a pretty successful system, and it'll let you move data very effectively without feeling like you have a lot of latency. So I mentioned to you this game. So here's the QR code. There's also the bit.ly link there if you want to use it. I don't know why I just didn't put the real, but feel free to take it, and I'll show you what it looks like. So I'll put that back up there in a second. So it should look like this. When you get it, it's an app. It has 3 buttons and has a color. So you'll make sure you put in this very top line here. I'll put the QR code back up again. But you create some unique player name. All your goal here is to put a player name in there. Let's do me. Can you go back to me? Yeah, I will. Pete demo. Put a name in there, and then you click a button. All right, so I didn't win it. You can't see it very well with the color, but the red button, it says find the red button, and the bottom button was red. Every time it changes, so it's not like you're going to just guess the last one. So all you're trying to do is find the red button. Is this the link? Sorry, I'm trying to find my presentation again. Come on. Oh, there it is. All right, so there's the QR code. So open up, try to get the QR code. If you need to know what the URL is, it's webtrends.github.io/IoT-game. I know I said that fast, but that's also the URL. feel free to do it, and it's going to be going on this whole talk, so you'll see me change different buttons, and I'll ask you to click it, and you get a chance every 5 seconds to try to pick the button. Whoever has the most correct button clicks gets the money, or some of the money, and then the person that comes in second gets some more money too. So anyways, everybody got the QR code? Take a picture of it and maybe do it that way too. All right, so let's talk about technology. I'm sorry? Oh. So the app here, this is a word cloud and I kind of talked to this already, but this is a word cloud about a blog post I just did not too long ago. And I already kind of did a survey here of how many people thought real time was like whatever. But if you look, this is like the highest response. Real time data, time, things, pipeline, those are all ingestion. Those are all terms that people think of when you think of IoT and analytics. So out of these words, the requirement for the technology is that it needs to be current, and it needs to be highly scalable, and it needs to be pretty expansive. So we're going to go through some of the details technology of what we built. So as I mentioned, we have a tag. That tag collects information. When that tag collects information, we dump it onto a Kafka topic. That Kafka topic is then transferred to our data centers from around the world. So we have lots of data centers all around the world, and they're all producing data. Those data centers then send it, or publish it to a topic, and the processing center reaches out to each of these topics and pulls the data, because that's how Kafka works. It's a pull, and it's a checkpoint. And along with that, the data then goes through a system that looks like this. We have a CDN, or a hosted tag, that collects the information. We have some processing engines that actually run in the data center that actually augment and modify that data set along the stream and also in the edge. And then we put in a streaming broker, which is Kafka. So we use Kafka both at the edge brokers in all the different data centers around the world, and then we have Kafka at the main processing center. That transfer of data over Kafka is what I consider the primarily way that we can actually move data as effective as we can. I mean, the old-fashioned method of log file delivery and log file movement was just archaic compared to the way Kafka does. And that's really the key differentiator for how the data in the modern world works compared to a legacy system. So we're going to ask you to find the blue button now, and I'll show you how this works and how the reason why I'm having you do this, guys. So if I go into Streams, this is our application, and I thought I had this running, but maybe I didn't. Oh, there we go. So this is a real-time system, and as you guys are clicking, we have a lot more losers than winners. So it looks like Stealth is leading the charge right now with 6 wins. And Edgar, there's some other people coming in here, but there you go. This is happening in real time, and it's reading or processing our real-time stream system. So as you're clicking, those events, you should click, and if you win or lose, you should see your number change in real time. And this is, when you click that button, it's sending an event to our API endpoint, hitting the Kafka topic. The Kafka topic is being augmented through the geolocation and the device stitching information and the personalization and the visitor 360 kind of view of who you are, getting attributed, and then I built this dashboard through our Streams product that basically just shows us a visualization of all the winners and losers. This is using the real-time streaming system pipeline. At the same time, we tee this off and we go to a storage mechanism for historical data sets. And I wanted to explain that to you because we're going to change this up and show you how that changes. So this is everybody that was looking for red buttons, remember. So I'm going to go here. This is how awesome I am. Here's GitHub. Everybody knows this. And I'm going to tell you, you now need to look for the blue button. Blue. I'm not doing a pull request. Sorry, guys. All right. So now the system, it will automatically pick it up, and it should change that icon in a few seconds once GitHub decides to push my change out to its CDN. It will, the app now, if I go back to this game app, see how it says red, if I refresh this. Oh, now it says please find the blue button. So your app should now have all refreshed to see find the blue buttons. And the reason why I'm doing this is I want different data sets available for us in this demo. All right, so I'll come back. Keep on clicking, guys. That stream, I want to see who's winning. All right, so as I was mentioning, so we're reading this data. Oops, didn't show up. There you go. So as mentioning, the data is coming off the stream, and this is what you guys have been seeing. The data is coming off the stream, it's getting separated based off the device, and then it's being energized with information through stream processing. Our stream processing is all being published to Kafka topics, and then we're taking these individuals and the devices and augmenting it with device data from NetAcuity, Device Atlas, all these different device information people. And then we're taking it and teeing it off to two options, making it available for real-time querying, which was what I just showed you, and also we're storing it in long-term storage in HDFS. So we're splitting that off into two venues. So what's that mean? So here's the architecture at a high level from our stream processing standpoint. So we ingest the data using Kafka and Spark streaming. So we're taking the data in. There's a Spark streaming job that's constantly reading this data off of Kafka and doing some sequencing and event sessionization. We also have, well, that's actually, I don't know why I put that there, but OK. And then we have SAMSA, which is a similar component to Storm. Personally, I'm a fan of SAMSA. It was about a year ago that we came around and said we're deciding to get off of Storm because we have issues with, in this case, we have to use it for reliability and durability. So in the case of Storm, it's good for some use cases. And I'm not saying Storm's not a bad product. It's a great product. We used it for many years. But one thing that SAMSA got for us is the ability to resume and continue to consume from where you left off the Kafka checkpoint. It's really important for us to not have duplicate data because we can't dramatically inflate our numbers. And secondly, it needs to be resilient to internet outages and other things. And the whole supervisor and some of the Storm stuff just created a lot of extra stuff that we had to do to make it work really well. So SAMSA, Scott, who's one of the primary engineers that worked on it, said, how much less code?
I don't know, but
like fractions. Like the amount of code you had to use for Storm, let's say, was 75% greater than what we needed for SAMSA, just because it's doing this type of processing. So if you're doing stream processing and dealing with data it's highly reliable and ordered and specifically needs to be guaranteed for delivery, an IoT system that doesn't use SAMSA, you are going to use Storm or you're going to use something like SAMSA. I would go towards SAMSA just because the way it works and how it's designed to work. And it was developed by the guys at LinkedIn, so it works really well with Kafka. I mean, it's just out of the box works. And it's been a workhorse for us. So that's where we do the augmentation and the work that we do with the geo data, and I'll show that to you in a second here. Then we also do some device stitching now, which is the ability to look at the different devices that the user had. So if you were clicking those buttons on multiple devices, and if your player name was the same or you somehow sent yourself a link, we can actually kind of infer what are the different devices that you have. So we also stitch those together to create a full 360-degree view of the user. And lastly, we finalize it out and we write the data out in Spark Streaming. And that's where we actually write it out to HDFS and HBase for some faster queries for mutable sessions. Because once you write something in HDFS, you really can't change it very easily without re-emitting it. All right. So if you have been clicking, this is the last button for you guys, just so everybody knows. Then we'll get into some demos. Go back over here. This is called change control. Green. All right, last. So let's go see if anybody else is still clicking. Oh, Edgar has taken the lead. Oh, no. There's a time window, so it's like within that 60 seconds. I can show you the final counts here in the end. All right. So I talked about, OK, come on. There you go. So I talked about the data that is coming into the pipeline. So after we process that information, I say we store it. So this is what it looks like for a storage standpoint. So we write the data out to HDFS. And HDFS, we use ORC files because it gives us the ability to scan the columns and see what data is in it pretty easily. And we store our data by what we call sessions, which is basically just a timed bucket of data that's related to a series of events that are for an individual. And those technically could be anything that we define, but right now we define it as 30 minutes of any number of events within 30 minutes of inactivity. It will create a new session, or a maximum length of 2 hours. So the idea is that we put all this data into ORC files, but each session is kind of stored with all the events together. We use a JSON object, we store this data, and it allows us to be able to look at the data very effectively and very quickly and pull it out and interrogate it. We also use HBase as a cache to store this data to make it very easily to aggregate those aggregatables back down again, because we can use coprocessors and actually ask and inspect that data. So between HDFS and HBase, it's giving us a pretty good sense of what are the open sessions, or what are the open active data feeds that are coming into the system, what are the visitors that are available to us, and we can get a large time frame view of that historical data set that's been coming in and ingested over the Kafka topic. One thing to really call out and note here is when you're dealing with a Lambda architecture like this, there are different types of SLAs that you would have to be aware of how to process your data. So in an IoT land, you're going to be dealing with lots of information that's potentially having different peaks and valleys of ingestion rates. So with WebTrends, we have thousands of customers that have to deal with data of all different sizes and shapes. But we don't have is a finite descriptive way of sending us data. Customer A may encode their data 4 times, customer B may not. It's one of the things that we've always had to deal with and fight with is, what should we do with the data as it comes in? My stance on this is, don't do anything. As a person who's producing data, your sensors, make it available to you to manage that data set on the way out. Take care of it when you're extracting it, manipulating it, querying it, decode it, trim it, slice it, split it, whatever you want to do it on the way out. This way, you have get it laid down in an organized way, but don't worry about trying to do a lot of sanitization on that data as it's coming in. You can always re-ingest it back into your system and produce a query and actually execute that data set and put it back in the system to do more further refinement. But leverage the power of the big data and embarrassingly parallel systems, because it allows you to farm this stuff out in a partitioned way, and you will be able to be more successful with the way you process that data long term. So all of our storage data is pretty much the way they sent it to us from the original source. So the last section before I start going to more demo and is about the technology that we use to process this data. And this is what we've been working on for the last year. This data has been dropped in. We spent the time getting the data for the ingestion and getting the transport in first. The second part we did was let's write the data out to HDFS and store it and make it queryable. Well, making it queryable is the last step, and this is the engine that we built on top of it. It leverages Spark, and it's a streaming system. So the idea is that because we're moving the data in a stream fashion, again, 500 milliseconds from the time we hit the edge to the time that it can be potentially stored, the system that's reading the data, we wanted the same thing coming out. So we didn't want like a request and response kind of methodology. We wanted something that I ask a query, and it emits the data through a WebSocket or a stream just as it starts reading it. So just as the data is coming in, we want to be able to read the data out. So the idea is that we can send this information out to the different systems, reporting applications, personalization containers, customer intelligence systems, big data infrastructures, and all that kind of stuff needs to happen in the same kind of flow as it came in. So really our goal is get rid of batch. Treat batch and the real time as one, but having a Lambda architecture that basically lets you do that. So this system is cranking out a lot of data. And one of the most recent components that we just built was something called the IDC. It's this Infinity Data Connector. And what we've done is, as the data is being extracted from our system, or actually just emitted, after it's been refined and sessionized and augmented and create valuable insights to it through our analytics engine, we dump it into an encrypted tunnel over the internet using Kafka again and SSL, and we push it into the customer's ecosystem in the end. So we're able to drive and deliver data into your data center in your Hadoop infrastructure or your BI solution or your Azures, your Redshifts, your whatever you want, S3s. And that data then can be consumed by your downstream processing. We leverage Spark Streaming for that again because Spark Streaming is so good at dealing with consuming off of Kafka and also being able to manipulate that data, as I was telling you, on the outbound. So we can say, let's turn it to JSON, let's make it flattened, or turn it to XML, or produce a file, or whatever you need to do. That little agent that runs over there on the client has a Spark Streaming job that runs in your ecosystem. So fast forward now, and let's think about what we've really talked about. First off, we said data ingestion is important to make sure that you move it as quick as possible. Secondly, we talked about having a processing system that's able to take that data and process it as it's happening, because a batch process is too expensive to come back and retroactively deal with as a primary source of processing. Thirdly, make the Lambda architecture split between your real-time IoT use cases and your persistent use cases. Just dealing with real-time from the standpoint of what's happening with the current data set that's on my site right now is great if that's all you need. But if you want to look at it historically, you have an option to persist. And lastly is being able to query that information. Whether or not you're using Druid, Solr, build something your own system off of Spark or some other big data solution, the idea is that if you can make that data available to the user as quick as it's been calculated upon, you'll get more valuable insight out of it. So let's look at the results of this little clicking exercise you have. So this has been going. And this is an events in the last 60 seconds. This is how many people have been generating data. So this is our Infinity application that I was telling you about that we built on top of our query engine. And what this has done is we can create interactive queries that are reading the data set that's been being processed on the back end by our streaming system. So it's both being streamed and it's being both done with the historical data sets. So this system is looking off of the HBase and the ORC files that are being produced. So I can create, and I have a segment here that says basically anybody that's playing the game, that they actually had a name. And so I just basically have, here's the number of wins and here's the number of losses. So Edgar has been clicking away pretty violently. He's lost 156 times, but won 71 times. Stealth is in a close number in second spot, and then Kirk is in third. And is it Texfin or Texlin? It's hard to see on this monitor. Texin is 36. So just gives you an idea. So you can also see how many events that they generated. So Edgar has generated 227 events totally. Stealth has done 181, and so on. You guys can read the data. But here's the cool thing about the system, and because we have all the raw data that's available to us in the raw form on the ORC files, we can inspect this data even further. So I say, OK, well, you know what? Let's see what type of devices they have. So Edgar is using his computer. Let's see if Stealth is using a phone. That's a type. Let's see. Let's get a name of it. Let's not just look at the device type. Device. This is really hard to do. Device name. Oh. Sorry. Can't see my clicking. There we go. So let's see what Edgar has. It doesn't know the devs. Of course, picking things that I don't know. Stealth has a Lumia 640 LTE. So here's an example of things that we can actually do and augment. I can add different measures. I can create different devices. All these aggregations are happening at real time on the Spark job as we execute. So it's a good thing to think about from the standpoint of when you're laying down your data. Time series can also be done really effectively and efficiently, because if you can organize your data in a set that's bucketed by time, the partitioning in Kafka becomes very easy, and at the same time, you can query it and look at different time ranges pretty simply. Let's see what other thing that we can look at. Let's look at the browser Edgar's using. So he's using Firefox and Chrome. So that's how he's winning. He's using 2 browsers. He probably is that. He's probably, what? Cheating. Cheating. There. I didn't give any rules, so I guess that's fair. It's good for him. But there you go. It looks like Firefox is winning over Chrome in his case. But do you guys see the power of this data? That's really my last slide that I wanted to share with you guys. So I would like to take some questions in the last 3 or 4 minutes that we have. Do you guys have any questions about the technologies that we've used and chosen pick from? Yes.
Are there any negatives to going with SAMZA as compared to Flink or Flink?
Flink in the sense of Spark and versus, that's a big debate that I don't really have time to get into. But my opinion on SAMZA is because SAMZA has the ability to read from Kafka directly or natively, and it works with, it's not the simple consumer, it's a high-level consumer, correct? I always get it backwards.
Yeah, it uses its own. I don't remember.
Yeah, it has its own under the covers, but it understands how to. It keeps its change log on there. It knows where the journal is. It knows how to consume, and it's durable. So like I could shut down the whole system and come back, and it would pick up right where it left off. And running it in Yarn, it just works.
The big deal between SAMZA and Storm is you have state with SAMZA. You can store everything in RocksDB.
Right.
And when you bring it back up, if your RocksDB data is gone, it'll just
Reload it from the journal, right? Because it just reads off of Kafka and just we can move it.
I mean, it's really it just goes as fast as Kafka and as fast as your code works. So.
Right. Yeah. So like if you're spending a lot of time processing in those tasks, regardless of Storm or SAMZA, you're kind of doing the same workload. So personally, SAMZA has been a lifesaver for us. I mean, from an operational standpoint, it's been just solid. It just kind of got to its 1.0 release, right?
It's at point
yeah.
10.
Let's call it. It's a stable release. So, other questions? Yes.
Yeah, thank you for that real-time example. Could you give us another example of a use case where this has come in handy?
Of like a real-time example use case. So WebTrends also does an optimization program. So we can take all this event data that's coming in on the site. So cart abandonment. Somebody's shopping on a website, doing something. They're ready to leave the site, but we predicted through our machine learning algorithms that we're looking at, saying, hey, they're ready to abandon because they put something in their cart, but they didn't click buy. Let's pop something up and say, free shipping. I don't know. I mean, there's lots of different ways. We have an optimization product that lets you do that kind of feedback loop. So all this data that's coming in real time, we can then turn around and take actionable contextualization around it and actually do something with the visitor. Responses, exact target, email, like, hey, you left something in your cart. You want to come back and actually go and book that trip to Tahiti that you wanted to take but you didn't buy. So that's another very common example that we see. I saw another hand, sorry. Well, thanks, guys. If you have any other questions, I'm around. So appreciate it.